Distance vector routing. First we want to write a table as a three columns like distance, destination one column, distance as one column, next to hope as one column. Find from A to A distance is 0. Next adder is also A. From A to B distance is 2. Next adder is B. From A to C, we can check here A to C. A to C there is no direct mapping, direct line, so we want to keep infinity, and next hope is not is there. From A to D there is a direct, distance is 1, and next hope is D. At B, find at B also. 3 columns, destination, distance, next hope. 3 like all the nodes are written as A, B, C, D. From B to A distance is 2. Next hope is A. B to B distance, self distance is always 0. Next hope is B only. From B to C distance is 3. Next hope is C. From B to D there is a direct map, distance is 7, and next hope is D. At C, find the 3 columns as destination, distance, next hope. Write all the nodes A, B, C, D. Now we want to find from C to A there is no direct mapping, so distance is infinity. Next hope is no, keep the dash. When the distance is infinity, the next hope is always no next hope, so keep the dash. From C to B distance is 3. Next hope is B. From C to C the self distance is always 0, and next hope is C. C to D distance is 11. The next hope is D. At D we want to find again at D, last final state. Here with 3 columns, destination, distance, next hope. The distance vector works on Bellman-Fold algorithm. Now the distance from D to D, A, B, C, D, all the nodes are written as A, B, C, D. Next hope, D to A distance there is a direct mapping, so A 1. Next hope is A. D to B, we want to check D to B, there is direct mapping 7, distance 7. Next hope is B. From D to C distance is 11, and next hope is C. The self loop is always 0, and next hope is D. After finding every table, we want to find the distance vector at A. Check the diagram at A. A is directly mapped to B and D. No C is not the direct mapped. So at A distance vector we want to find from B and D. And again check at B. At B there is a direct mapping between C, D and A. So distance vector is from A, C and D. Next at C the direct mapping is D and B. A not is there because it was no direct mapping. So C and D. B and D distance vector from B comma D. Let's see. Next at D we want to find a distance vector from, check the D, direct mapping is from C and B and A. So A, B, C. We want to check distance at A, distance vector from B and D. B and D. We want to cut from B and D. Check here. From B. Here is the A. Here is the A. And check this. 2037. B values we want to write 2037. And D values what are they? 1710. 1710. Okay, from A to find the distance to all three nodes, A to B, A to C and A to D. A to B, how many ways we can go to, how many, here check how many ways we can go to B. Here is the one way, and A to D, B one way, A to D to C and C to B. These are the ways. So we want to select from minimum. A to B direct mapping. A to B plus B to B one way. A to B, next node is B, so B to B one node. Next A to B, A to D plus D to B. We want to go to the stage of B as A to D and D to B. Again one stage is there, A to D, D to C, C to B. We want to take the minimum distance. Minimum distance means here we check 11, 3, 4, 1. Total is 15. It was long distance. So we want to remove this. No, we want to not write in this. Long distance or remove. Next A to C, minimum distance. A to C, minimum distance. Check here, minimum distance from A to C. The ways are want to check the, go to the C is A to B, B to C, A to D, D to C. And here less distance is, again we want to go A to C as A to B, D to B, B to D and D to C, but the distance is very high. We want to remove this. Check here. Now from A to C we want to check the distance from A to C, whereas paths from A to C, A to B, B to C is one path, A to D, D to C is one path. We want to take minimum from this. A to B plus B to C is one way of approaching, and another way of approaching is A to D plus D to C is another way of approaching from A to C. Next, minimum of, we want to approach from A to D. Here is the A and here is the D. A to B and B to D, one approach. A to D, direct one approach. A to B, B to D is also one approach. So we want to find the minimum of A to D plus D to D, and again A to B plus B to D. Now we want to find the distance of minimum distance from this. A to B, check the distance. A to B 2 plus B to B is self loop is always 0. A to D, A to D distance is 1 plus D to B, D to B 7. Here is the total is 2 and here total is 8. We want to take minimum of this. Minimum of this is minimum of 2, 8 is 2. Next A to B distance. A to B distance is 2. B to C distance. B to C distance is 3. A to D distance. A to D distance is 1. And again D to C. D to C distance is 11. Here 5, 3 plus 2, 5, 11 plus 1, 12. 5, 12. We want to find a minimum of 5, 12 is 5. Minimum of, next we want A to D. A to D distance is 1 and self loop is always 0. Next A to B distance. A to B distance is 2. B to D distance. B to D distance is 7. Here the total is 1 and the total is 9. Minimum of 1, 9 is 1. Make a table at A. Has 3 columns, A, B, C, D, and A to A self distance is always 0. A to B, we want to find the A to B minimum distance is 2. Minimum distance 2. Next approach is B. Next A to C. A to C distance is minimum is 5. Minimum 5. Next approach is B. Here we check A to C is C distance come from B. So B we want to write as B. Next A to D. A to D distance minimum is 1. Next state goes to D. D 1. You want to check one distance. The final state is D. Same. After completion of A, now we want to find the at B. Distance at B. At B. Here check at B what was distance was A, C, D. We want to write the columns of A, C, D distance. Here A, C, D distance. We want to write these three distances. From A distance is 0 to infinity 1. Next from C, at B we want to find ACD distance. We want to write the C distance. Check C distances as infinity 3, 0, 11. From D we want to see the distances 1, 7, 11, 0. Find the distance from. We want to go from B to various distances like B to A, B to C, B to D. B to A as one distance. B to B self distance, no, we don't want to calculate. B to C as one distance, B to D as one distance. B to A, we want to find minimum distance because of Disgust algorithm, Bellman-Fold algorithm. Minimum distance from B to A. Minimum distance from B to A. We want to go B to A in different paths, but we want to find the minimum distance. From the diagram we easily find that B to A distance is 2, and the next approach is B to D, D to A. It was long, so minimum we want to find B to A one distance plus A to A. It is the minimum distance. B to A and A to A minimum distance. B to A distance is 2. B to B distance, A to A distance is 0. Next approach, B to C. B to C. Here check B to C. 3 is the minimum distance. B to various approaches like B to C, B to D, and D to C. But we can with naked eye we can find that easily that B to C 3 is the one distance, and B to D, D to C is long distance. So B to C plus C to C. B to C distance is 3. C to C distance is 0. Next we want to go from B to D. B to D. Here B to D. B to D we want to go. B to D 7 one approach. B to A to D another approach. So we can write minimum of B to D plus D to D, and again B to A one distance one approach, B to A and A to D. B to A plus A to D. B to D distance is 7. self loop distance is always 0. B to A. B to A approach is 2. A to D. A to D approach is 1. So we can easily minimum of 7 comma 3 is 3. Here 2. Here 3. We can write for distance vector at B. Table distance vector table at B. A, B, C, D, and again here distance A to A distance is 0. A to B, B to A distance, B to A distance is 2. B to B self distance is 0. B to C distance is 3. B to D distance is 3. Last approach is A. B to A last approach is A. Check here. B to B self distance is always B only. B to C. B to C. B to C self distance is C last approach. B to D last approach from minimum. Minimum is 3. Minimum is 2 plus 1. So we want to write as D. Next at C. Now we want to find at C. At C we have B and D. So from B, from D, here we check that B distance is 2037. Write this right here, 2037. And from D distance is 1710. 1710. Now we want to find the distance from C to minimum, C to all nodes. C to A as one node, C to B as one node, C to D as one type. C to A. Find the minimum of C to A distance. Check here. From C to A. C to A. The diagram easily says that C to A is 3 plus 2, 5 distance. Now C to A another approach is 11 plus 1, 12. So it was long distance. So we want to write C to B and B to A. So C to A, C to B plus B to A. It is the minimum distance. C to B distance is 3. And again B to A distance is 2. The minimum distance is 5. 3 plus 2, 5. Next, minimum of C to B. We want to find the distance C to B with minimum distance based on the diagram. C to B 3. Minimum distance is we can easily find 3. Another approach is C to D, D to B. It was long, so C to B is the minimum distance. So we want to write C to B plus B to B. C to B distance is 3. B to B self distance is 3, 0. So we want to write minimum distance as 3. Minimum of C to D. We want to find minimum of C to D. C to D minimum distance is 11, one approach, and another approach is C to B and B to D, another approach. We can check C to D long distance 11, C to B, B to D 10 distance. So we can go another approach, C to B, B to A and D to 1, 3 plus 2 plus 1, 5. So it is the minimum distance. We want to go C to B, B to A and again A to D. Finally, the conclusion is the minimum distance we want to check from the given diagram. So C to B distance is 3. B to A distance is 2. A to D distance is 1. So minimum is 3 plus 2 plus 1, 6. We want to write a table based on the given answers. Write one step as A, B, C, D, and the distance is here, and the next hope is here. Next hope is always this. Next, from C to A distance, minimum distance is 5. Next hope is B. Next hope is always this B. C to B minimum distance is 3. C to C self distance always 0, and the next hope is C. C to D minimum distance is 6, and the next hope is B. Here also next hope is B. Next, at D we want to find at now at D. At D, we want to find from distance vector at D is B, A, B, C. We want to write the A, B, C distances. From A, from B, from C. Check here. From A distances. Given diagram, A distances 0 to infinity 1. 0 to infinity 1. From B distances 2037. C infinity 3011. Now we want to find the minimum distance from D to A, D to B, D to C and D to D. D to A minimum distance find, D to B minimum distance find, D to C. D to D is self loop, we don't want to find this. D to A minimum. From diagram D to A minimum approach we want to go. D to A, here easily find that D to A is 1. So D to A plus A to A. D to A distance is 1. A to A distance is 0. So minimum distance is 1. Next D to B. D to B minimum distance is, here is one approach 7 and D to A and A to B is the minimum distance. D to A and A to B minimum distances. So D to A and A to B we want to go of D to A plus A to B. D to A, here check that. D to A 1 and A to B 2. 1, 2. Minimum is 3. Next minimum of D to C. We want to go D to C with minimum distance. D to C here is 11. And another approach is D to A to B and B to C. It was 6. We want to find minimum distances. D to A plus A to B plus B to C. D to A distances. D to A 1. A to B 2. B to C. B to C 3. 3 plus 2 plus 1. 6. Minimum distance. We want to write the table. A, B, C, D. Minimum distances. Here we find that D to A 1. Next stop is always this. A. D to B. D to B 3. Next stop is A. D to C. D to C 6. Next stop is A. D to D 0. And the next stop is D only. Finally this answer was completed, and the diagram is A, B, C, D, 11, 3, 7, 2, 1. All the tables at A, at B, at C, at D, we find the tables are inserted here at A. Here we find at A the table we want to write here. A, B, C, D, 0, 2, 5, 1. 0, 2, 5, 1. And the next stop is A, B, C, A, B, D, double B, D. Next at B. At B, we check. At B. At B, the distances are A, B, C, D, 20333. 2033. Distances are A, B, C, D. Next at C. At C we get a table like as A, B, C, D, and C distances are 5306. 5306. Double B, CB. Double B, CB. Next at D. At D we find that minimum distances are this one. A, B, C, D. A, B, C, D. And the distances are 1360. And the next stops are triple A, D. triple A D. Finally, the first state of distance vector is this, and the minimization, after minimization, the distance vector table is converted as this, like all the infinities are removed. Here we check that infinities it was removed here, A as 5. So the distance vector, we can reduce the distance while calculating.